Hello, and this is a review of what we are going to be covering for the expressions test for our math class. And here are the topics that we're going to be covering: simplifying expressions, distributing, multiplying fractions, prime factorization, greatest common factor, generalizing patterns, and percentages. Now, I wanted to make this video because I want you to be prepared for this test and also so that you can really have a good set of notes. And so here we are. I'm just going to run through these topics now. So remember, with simplifying fractions, we have these 4 steps where you want to first change subtraction to addition. So here, if I have minus 2x, I can do a plus, and then I need to change that term into a negative, and then I can do the same here. And then once I do that, I want to see, do I need to distribute anything? Now in this problem, I don't. But in other problems, we might. So like this is the example of the distributive property here. But now that I don't have to distribute, then I want a group term. So remember, I want to take each step one at a time and rewrite the problem. So I'm going to keep the first term, and then I'm going to move over the 8x, right, because that goes over here. And then I'm going to add 7 plus negative 2x. Now look, I made a mistake, right? I have 3 terms that are the same, so I want to put them all together. So let me go ahead and just undo that, and I'm going to add negative 2x, so that one goes there, and then I had the remaining terms plus 7 plus negative 9. So I'm actually not even doing any adding right now or subtracting. I'm actually just grouping the terms. But when I combine, that's when I want to really do some of the adding and subtracting that we do in our mind. So here we have 4 plus 8 is 12, and I'm adding a negative 2, so that's going to be a positive 10x. And then I have 7 plus negative 9, which is just going to be negative 2. So 10x plus negative 2 is our answer for that. Now, for distributing and multiplying fractions, remember, when we multiply fractions, we just multiply across, okay? And so a times c is just ac, and b times d is just bd. So if we had, 3 over 5 times, I don't know, 10 over 6, remember, you just want to multiply across, and then you always want to be able to simplify, and so you can get 30 over 30, which is just 1, okay? Now, we need to know how to do this in the event that we have to multiply a fraction with a number. So that's the example here. So we want to apply multiplying fractions to this problem right here, down here. But first, let's just go over distributing. Now remember, if I have 2 with a parentheses by itself, like 2, that means multiply, right? So I have 2 times 2 here, which is 4. But sometimes inside the parentheses, things can get bigger and include something more, like x plus 2. But we still can distribute into both and multiply the 2 here by both terms on the inside. So let me just make this very clear. So if I make this 2 blue, then I have 2 times x, right, plus, and then that same 2 again times the 2. So that 2 gets distributed, and so I'm left with 2x plus 4. Same thing here. Even though it's a fraction, I'm still doing the same thing. So I get this 1/3 here, right, gets distributed into both terms. I have 1/3, okay, times 4x plus 1/3 times 6. Now remember, when you're multiplying a fraction with a whole number or an expression with just like 4x, remember that is 4x over 1 and 6 over 1. And so we are just multiplying across. And so you get 4x over 3 plus 6x, or excuse me, just 6 over 3, because 3 times 1 is 3, 3 times 1 is 3 down there. And then I can simplify this to 4 over 3x plus 2. Okay? Now, for prime factorization, we learned, this is something that I think we did a pretty good job of working on. But remember, we want to just go ahead and do the factor tree. So these are even numbers, so I factor out a 2. And then I want to think, well, 52 divided by 2 is going to give me 26. And then I can take out another 2, and that leaves me 13. And then I can do the same thing with 106. Now, for 52, it's going to be 2 squared times 13. Right? And then 106 is going to leave me with 53. And then it looks like 53 is a prime number. Right? Nothing can go into that, like 2 or 4 or any even number. And then 3 doesn't, 5 doesn't. 7, you would get 7 times 7 is 49, and then it jumps up to 56. So it's safe to say that we have this as a prime number. And so the GCF of this is going to be the pair just with the 2's. So the GCF is going to be 2. Now remember, if there was another pair, we would just multiply. But since we don't, the GCF is 2. Now what I want you to remember is that we can do this same idea with expressions. But now we have an x here and y, and we have just an x here. Right? So what we want to do is we want to still, see, we can still give our factor tree here. Right? This is 2 and 53. But now, as you can see, we have 2 again, like the previous problem over here. And then they also have an x. Okay? And so we can take away the GCF as 2x. And we want to know how to do this so that we can actually factor it. So like if we were to actually get the problem, 52x squared y plus 106x, we could actually factor out the 2x, and then we put in what's left on the inside. So we have a 2 here, a 13, an x, and a y. We want to multiply that all together, and we get 26xy, right? Plus, again, we want to find what's remaining here, the 53. So we type that 53 there. And then the x has gotten taken out, so that's all that's left there. And so we're done. Now for generalizing patterns, remember, it's always good to make a table. So here we can say these are the figure numbers right here. And so we can say figure numbers. So 1, 2, 3, 4. So we want to predict what the fifth one's going to be. And then we'll say here number of blocks, right? And so here we had 1 block. And then if you were to count 1, 2, 3, 4, you would have 4 blocks. And then here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Get 9 blocks. And so what you want to do is try to recognize a pattern. How do I get from my figure numbers to the number of blocks? And if you notice, 4 was 16. And so if you could count, you can draw 5, right? So you know you're going to have 1, 2, 3, 4, 5, right? So you know that's going to be 25. So it's basically 4 by 4, 3 by 3, a 5 by 5, right? And so you know that you're going to have 25. And so it's just the side squared. And so for a general n, for the figure number, you want to do n squared. Okay, and so that's basically generalizing the pattern. And so if you wanted to figure out what, like, let's say maybe the 10th figure would be, well, just multiply 10 squared and you get 100. So it'd be 100 blocks for the 10th figure. And then lastly, with percentages, remember we wanted to get better at figuring out percentages in the quickest way possible. And we do that by actually working out a table. So if we have increase by, let's say, 7%, remember we want to take the whole amount and then add 7% of the amount. Remember, we can combine those and we get 1.07x. So if we wanted to find that increase, we would just multiply by 1.07. Here we have a decrease, by, let's say, 10%. So we want to take the whole amount and then subtract 10% of it. But then we can, again, simplify this, and we're going to be left with 0.90x. So that's the same thing as multiplying by 0.90. So if you notice, anytime you're increasing, the value is going to be bigger than 1. But when you're decreasing, the value is always going to be less than 1. Okay? And we could just keep going, but the pattern remains the same for any increase or decrease. So that is the test that we're having on Wednesday. Hopefully this is helpful. I'm hoping that you can put these things on paper for your notes so that you can do well on the test. Good luck.